All right. Welcome. Thanks for joining us. My name is Colin Bowen. This is Designing API-Enabled Applications in the Architecture track, just to make sure you're in the right place. And thanks for coming out. I want to tell you a little bit about what it's going to take to build a great API. But first, I want to kind of tell you a little bit of a story. About 10 years ago, I was working in a startup building websites for rock stars. You probably know a few of them, Keith Richards, Roger Waters, Ted Nugent. And our CEO came to me and said, I heard about this thing called an API. What are we doing about building an API? And at the time, there wasn't a whole lot of hacking on APIs like you have today. And I thought, we don't need an API. Let's just focus on building great experiences for music fans to connect with their favorite artists. And so, I kind of dismissed it. And here we are 10 years later going, geez, I wish I built an API. Because they're actually kind of all the rage these days, and you hear about companies being bought and sold because of the APIs and services that they offer, as well as, as a developer, your ability to access and gain new functionality for your app very easily through APIs. And it doesn't matter what field you're in, there's APIs out there for it. So whether it's things like in the entertainment field, figuring out what artist is touring where, whether it's getting the current weather, the current stock prices. These are things that are now accessible to you today, whereas 5-10 years ago, wasn't quite as easy and accessible. And we're seeing this when we look at the numbers. The amount of API growth in the last couple of years has just started to skyrocket. And this is kind of going up, more and more even this year. I don't have the final numbers for the year, but you can see certainly there's lots going on in the API space. And the reason this is important, and you're thinking to yourself, I'm a developer, why do I care about this, is because APIs are actually important for your customers as well as your potential future business partners. Customers want access to APIs because they want to get access to their data in your systems. They want to do interesting things with that, and chances are they're going to come to you and say, I'd really like feature X, and you're going to say, ooh, I'd love to get to it, but my list of things to do is a mile long. And so I don't really have time to do it. And if they had just an API, they could go build that themselves. In addition, APIs open the opportunity for new people to do new and interesting things on top of your business. So if you look at, for example, what's happening today in the travel industry, the amount of sites out there that offer things like guidance on, is my flight going to be late, or how do I find the best price? A lot of those companies have been started because somebody in the airline industry and the travel industry offered up the data via an API. And so as a result, we have a whole new set of businesses trying to solve common everyday problems through APIs. And this is an opportunity as well to charge access to some of those APIs. And we'll talk about monetization in a little bit. And APIs are also important for you internally because it helps you, if you're thinking in APIs, you start to enable the opportunity to present your data through multiple channels, not just building web applications that access your data, but also the ability to build mobile applications. And that's kind of one of the bigger motivators these days in a lot of organizations is the idea that the CEO comes to you and says, I want a phone app. How do we get there? And you're like, well, we just built a web app. Can't we just add HTML5 and make it responsive and so on? But chances are you want some of the native extensions. And so if you have that API, the ability to kind of go build that app in parallel to your web app makes things a lot more tenable. Of course, creating a good API is actually really hard. It's not a case of build it and they will come. You actually have to think about this as a value channel for your business. And so you have to make sure first off, it's valuable. We're not just going to build the fart app of APIs where, just because I have an API, suddenly I'm going to get rich. I also have to think about it as a business plan and a model. And this is something that, as from a web developer perspective, we learned a long time ago is that these are channels that you're going to have to groom over time. You're going to learn about, and you're going to have to continue to invest in. So there's got to be, from a business perspective, value there that's worth your company investing in building and managing that API. And at the end of the day, you're actually going to have people using it, and they're going to have questions. So you got to think about, how do I support this API? I can't just put it out there and leave it and assume that everything will work just fine if you want to gain traction around it. So it's really hard to build a good API. It's something that takes time. It takes many iterations. This isn't just a version 1, ta-da, and then walk away from it. It really is a channel for your business, and you should be thinking about it in terms of the business terms. And there's actually a great talk from OSCon that talks more about the principles of building a good API. Now, if you've already ventured down that route and you've built an API, there are some signs, some anti-patterns, if you will, of things that you need to watch out for. And we're going to talk a lot about today about kind of what are some of the technical things around building an API. But these are things that I kind of want you to kind of keep your eyes out for. One of the most common ones that I see, and this is a great example of technology that demos and makes it easy, is exposing the raw data model. So if you've seen a demo, for example, for whether it was RIA services back in the Silverlight day or WCF data services more likely these days, it's like, oh yeah, it's great. Here, just put an OData service on top of your database and you're off and running. And when you're building a good API and thinking about the use cases, chances are they don't map 100% to your underlying data model. You're making choices in your data model either to support an internal application or to conform to the limits of some sort of pre-existing schema. And so you don't want your API to expose some of those limitations. You really need to be focused on the interfaces, the contract points, being appropriate for the use cases. And a lot of times that's not your underlying data model. So as much as it's great to say, here's Entity Framework, slap an OData adapter on it, and you're off and running, that's not an API. You also want to think about the protocol which you're going to write your API on. And today, by and large, it's we know it's HTTP in a lot of cases. It's just become the de facto protocol because it's easy. There's lots of tooling out there. It's well understood. It's cross-platform. And so today, as we kind of dig into the technical, we'll talk more specifically about building an HTTP-based API. But a lot of the same issues and concerns apply whether you're building a kind of a proprietary TCP or UDP API or some other protocol, richer protocol. So one of the things I do want you to think about as you build APIs, though, is it's not good enough just to write a bunch of tests around your API and say, hey, it's going to work. You need to build an application as you're building the API. And so as I work with teams to build their first sets of APIs, we usually do it in the context of your own company's app being the first and best consumer of the API. And so a lot of times, for example, today I spend a lot of time working on web projects. The web app that we build will often be the first consumer of that API. And so we'll kick the tires first, we'll learn the lessons, we'll cut the teeth first, and do more than just kind of write some unit tests around the API. We'll actually go and use it and make sure it performs adequately to build real other applications on top of it. And so you really want to think about designing your API not just in a vacuum, but ideally with some sort of companion app that will use it for the very first time. The biggest things you need to think about when you're building your API is what style you're going to take. And there's a couple of different styles. There's a book called Service Design Patterns that talks about these in a lot more detail. But you're either designing an API that's RPC-oriented, message-oriented, or resource-oriented. In our demos, we're going to focus on just the resource-oriented side because RESTful APIs seem to be kind of a hot thing, but it's equally valid to build a message-oriented and RPC-oriented API these days. Again, it depends on your use case and what it is that you're trying to build. The kind of important thing, though, is to make sure you don't mix the concepts, because as a developer using your API, if you suddenly go message-oriented on me and I'm expecting RPC with kind of parameters and so on, it's a really confusing experience to work with. So much like anything, architecture plays a role in designing your API and deciding the styles and patterns that you're going to apply. But all this theory aside for a second, let's actually get into building an API. All right, so I've got a sample web app that you might have built at some point, and it already kind of has an API today in the sense that we built this web app. It uses Ajax, it does some callbacks, and so I've kind of got this starting point for an API, except it's very much meant as an isolated private API just for my application. So let me just show you the app in a little more detail here. So we've got this tasks app. If you've ever seen the to-do MVC framework, it's just to-do lists have become kind of the de facto demo app. But if I look at what's actually happening under the covers here, if I pull up my network tab here, what I'm doing here is I'm actually making callbacks via AJAX to an internal URL endpoint to actually interact with my data set. And a lot of people have built apps like this because they've wanted a responsive website, and so AJAX was kind of one way to do it without refreshing the page. And unbeknownst to you is you've actually built an API. Now, people may not have put as much thought into things like the URI design or what the HTTP verb is. They might have just done straight get post type patterns into kind of random endpoints. But effectively, you started down the path of an API. So this is one of those scenarios where it's like, maybe we should just take that one step further, build a real API, we'll use it in our app, but then I'll be able to expose it to my partners and customers to be able to do even more interesting things with. So let's take a look at what we might have done, like I say, back in those days of AJAX. So if we pull up the controllers here, this is just a straight MVC app. We might have set up our controllers with, let me see, stop debugging here, straight kind of HTTP actions here that will go in and get the data, and it'll be very aware of things like response formats. It'll make a lot of those decisions ahead of time. This is what we would have done in the MVC days to get kind of AJAX working. And this really worked great for when you have a private API, but it's not quite as scalable and not quite as nice to maintain when you have actually a full-on API where you're trying to do things in a more public manner. Things like, for example, deciding format is something that really, why should I care as a consumer? I should be able to get my data back in XML or JSON or whatever format. Other things that we have to do by necessity to get the MVC framework to work, with this sort of API design is things like, caller action methods all the same and use these attributes. That isn't very natural. But this is something that, again, we would have done to get it working for our web app back when we built our web app. And there's better ways to do that. So let's actually go ahead and see what it takes to actually build an API. And we're going to use the ASP.NET Web API framework. And again, just as a note, this is only one of many frameworks. You've probably also been exposed to WCF in the past. Another way to build a framework or build an API. However, honestly, based on my experience, HTTP kind of has won the war in terms of protocols. And so I would encourage you, especially if you've never experienced WCF, to go down the ASP.NET Web API area first before you encounter some of the joys, I will say, of using WCF. And I see a few smiles in the audience of people that have had that pleasure. So let's go see what it would take to build this in more of a proper API format. So let's go ahead and add an APIs folder, and we'll go ahead and add a new class. We'll just call it the same task controller. And we'll take a look at here what it means to build this, and to make it easier to compare, let's put it side by side just so you can see here. So the first thing I need to do is create a controller, and I need to actually go ahead and derive from a class. In this case, we'll actually derive from API controller as opposed to a regular controller. And the differences are really under the covers in terms of the expectations of the message. So here, for example, I'm returning an action result. In an API controller, I can actually just return a set of data. And the API controller will be responsible for determining what format it needs to return the data in. So let's go ahead and copy my action method back here. And this time, instead of returning the actual format here, I'll just return the data, and I'll let the data where as no tracking. Oh, sorry, I copied it from the wrong method here. Where's the? Oh, okay. Oh, that's right. In the other one, I had actually populated on first run. Oh, dun, dun, dun. It's a joy of running preview. Actually, I think that was actually one of the add-ins. So luckily, they've built a little bit of process resilience in Visual Studio here. So let's. So this one, I'm just going to get the data where. Oh, I did the toList call up here. All right. So why aren't you resolving? Possibly because. Oh, I imported the wrong type. It's the problem when you pick the type names based on the .NET Framework equivalents. So let's kind of just take a look at the difference. So these two methods do kind of about the same. except that this actually returns the full list, whereas this one here returns either optionally the whole list or individually the ID. So we need to buddy this up with another one here that just gets me the ID. So just to show you what that looks like here. Let's get the data. And now we need to return the data. All right, so we'll return the data. So what we've done here is really just kind of simplify the API here. So we've gone out and said, we can go ahead and get the data, in this case on the right here, because under MVC I've got this kind of limitation here where if I include nullable parameters or not, it needs to determine which route it gets to. And so I have to write some of the complexity into my logic here to do that check and do some branching. In Web API, I can make just very clean methods. One method that goes and gets everything, one method that gets an ID, and return the result. And so I get much cleaner methods here that will go ahead and return the data. And again, they just focus on going and getting the data and returning it. And when you're designing your API, you want to think about very simple methods that you call. If you've got all these, if I call this method and you send in this, then it does this, it's really confusing for troubleshooting when you don't have access to the server side for developers on the other side. And so you want to think about very simple methods. Web API is going to give you that ability to have a very simple method to be able to go ahead and do that with. So the other key difference you'll notice here is the lack of attributes. There's no need to wrap anything in AJAX only and these HTTP GETs. In fact, I don't even need to worry about as much the name. I just actually call it the HTTP verb that I want to access. And so I get here as opposed to index and trying to guess which index. It's very clear what method and what it is what the intent of the method is. And so I can go ahead and continue to fill that out and do that with other things like, for example, post. And so I'm going to also have a little more control because I've decided on things like the fact that I am using HTTP to be able to change the behavior of how the application responds. So let's go ahead and send back this time an HTTP response message because I'm going to go ahead and post a task in here. And when I'm picking HTTP, I want to think a little bit about what's actually happening underneath the covers. In this case, when I'm posting back here before, really all I do is return the item. When I'm designing for HTTP, when I do a post, I'm actually expecting that I'm going to get back the location of the item and let the browser go request that item again. I'm not going to send the entire object back. So we'll go ahead and bring over our logic, which creates the item. Let's keep this in line here. Call this model. And again, instead of returning the JSON, what we're actually going to go ahead and do is craft up a new response. And this time, send it back the location as to where to get the, not the response, HTTP status code dot created, and we'll pass in the item along with that. So we're going to basically tell the guy on the other side, hey, if you really want the item, go ahead and find it in this location. And by the way, here, location is equal to new URI link. I'm going to use the default API route. And this location here is here's the URL to that item. Oh, that's just warning me. Okay, so what we've done here is we've changed the behavior a little bit to conform a little closer to HTTP. And so the expectation when I'm hitting an HTTP API is I'm going to go ahead and post the item, but it's also going to give me a link as to where I can go find the item again. Back here when I was building my private API, I just kind of returned the item in JSON, didn't worry about that. And so when you're building a public API, you want to think a lot about the semantics of the protocol you're working on. And with HTTP in particular, there are some nuances to be aware of. It's not just kind of URI design, but also behavior when I do a put, a post, a patch, a delete. There's some expectations behind that that you want to conform to. And again, Web API is going to give you a lot more flexibility to be able to respond in appropriate ways. Deleting the task is a little more straightforward. So in this case, we'll just do a delete of the ID. Go ahead and copy over our item here that allows us to delete. And we'll go ahead and delete it. In this case, we actually don't need to send any sort of status code back because by default, it's going to, when I do a void, it will send an OK. And then I need to also deal with updating the task as well. So public void put. So again, just kind of in comparative here. Here I was going ahead and putting in the task. And I would go ahead and send the response. In this case, I can just simply accept the update and do nothing to return that OK. The other nuance in Web API is because it works without this concept of action result, if you want to change the error code, you actually can throw new response exceptions when there's something that's not part of the norm. So in this case, I'll throw an exception saying that it was not found. This feels a little bit weird, but kind of throwing exceptions for flow control. But that's certainly a downside, or sorry, a nuance in the framework. So all in all, these two things look fairly similar between these two, kind of building an API using Web API versus building an API using kind of straight up MVC. What you get in the end is something that's a little more cleaner in terms of I don't have these attributes, I don't have these hacks around action names. And ultimately, I've gotten for free out of this the support not just of JSON, but if my client makes a request saying, give me the XML version, it'll actually go ahead and return the XML intelligently. And on both sides, if you've worked with MVC before, MVC has a rich pipeline that you can extend and make changes to, and we're going to see some of that today. You'll also get that in the Web API world. So if you come from the MVC world, jumping into Web API, really, really natural. If you come from the MVC world and you jump into WCF, not quite as natural. In fact, more laden with configuration. So things to kind of be aware of is that picking your protocol kind of matters. Don't take that decision lightly. And I'd really encourage you, if you're really building for a public world, to go ahead and pick HTTP as your default protocol, and then let that guide you to find the framework that supports that. In this case, Web API is purpose-built for HTTP, whereas WCF is kind of agnostic. And you may think, hey, that sounds great at first, but you pay a lot later in terms of the abstraction tax on the WCF world versus trying to get something up and running on this. So let's actually talk a little bit about some of the underlying design concepts here that you need to think about as you build that API. The first thing is when you're building a resourceful API, and I'd argue this actually applies to RPC-oriented, and it's like the same sorts of messages apply to RPC-oriented, message-oriented, is you need to think about your URL. It actually matters because we want to discover things, we want to be able to understand things through natural patterns. And so when people just put /blah on the API, or sorry, on the URI, it makes it really hard to discover, and I've got to read documentation, I've got to look at examples. When you follow conventions, such as in resource APIs, we have this convention of /collection/ID. It makes it really easy to, without reading the documentation, grok what is going on. And I mean, I don't know how many people read documentation as their first step. Most of us kind of just pop into code and start hacking away at it. This makes it a whole lot easier. So you really want to think about your API, when you're designing your API, what are the URLs? And of course, the natural first question comes up is, what are my collections? What am I doing with that collection? For example, I definitely get that there's a /orders collection. But how do I, for example, make a payment to that order? Do I have a /order payments collection? When you're designing these sorts of APIs, it's okay to graft actions onto the end of collections. So for example, if I wanted to trigger a state change on an order, such as making a payment against that order, I might do /orders/1234/ pay for order or payment. And I'd allow an HTTP post against that to trigger a payment against that order. And when I look at that /orders/1234/payment, that kind of makes sense. That URI speaks to me as a developer. So I want you to think about your APIs. And again, there's not a lot of hard and fast rules around what your collections are. You're going to learn that by building applications on your API. And this is why I go back and say that when you're going to go build one, make sure you do it alongside building an app that uses that API, because it will inform you as to whether or not you got things like the URLs correct. The other thing you need to be aware of, in particular when you're picking HTTP, is the different verbs out there. Again, this is where I was mentioning a lot of people back in your Ajax days, when you're building that kind of pseudo API under the covers, you're used to kind of using just get and post. Unfortunately, there's not a lot of information when you call get and post that really tell you a whole lot about what it is that you're intending to do. HTTP actually has a lot of rich verbs. And so this is where you want to think about how you use those verbs and make sure that they tell you something. So again, back in that pseudo API days, I would have put in a /delete orders, and I'd say just post to /delete orders with the ID that you want to delete. Well, why do I need to do that? I've got a verb called delete. I can just do /orders /1234 and use the HTTP verb delete to initiate an action. Likewise, if I want to insert versus update a record, I've got things like post versus put. And again, this is something where once you pick your protocol, you can dig into some of these semantics and use the right verbs that mean the right things. So there's some really kind of great stuff when you pick a protocol and get to know it. And so I'd encourage you, again, if you're going to use HTTP, get to know the protocol itself, not just the tools built on top of it. And it'll help you with some of the design choices. Just a quick note about kind of the update process. For example, there's patch and post when it comes to doing a change on an item. We've got a couple of options. The community hasn't settled on necessarily one. So for example, if I want to mark a task as /complete, I could do a HTTP post /task /1/complete, and that would go ahead and allow me to do that. Or I could do a /patch tasks1 and then pass in essentially a diff saying, here's what's changed. There's no real consensus on which is the right verb. Personally, I'm still in the option 2 camp because I find it's easier for most of the consumers of the APIs that I work with to consume. It also allows me to do the hypermedia thing where I can, in my data, describe, hey, if you want to do an action on this entity, here's a link to go do that action. And that's most important if you're really trying to move towards this truly RESTful services. And so that matters if you're doing a kind of a resource-oriented API. It's self-describing in a lot of ways. Here's the actions that you can perform on this resource you're entitled to. The other thing as well that matters is the return code. And again, this is something where in the MVC world, because I'm just returning JSON, I don't actually have a chance to specify the result code easily. And so you really want to think a little bit about what are the result codes that you're sending. And again, they mean stuff. For example, 200 versus 202. There's a slight nuance difference, but if I'm consuming your API and you give me a 200, I'm assuming you've got my message, you validated it, and you've already processed it. Versus if I get a 202 back, you got my request, and it's sitting in a queue and has yet to be processed. And so the nuance here is basically, I'm going to get 202s back when you're overloaded and you're just queuing up messages for processing later, versus 200, you've actually got my message and it's already good. Redirects, we'll talk about redirects in a second, because unfortunately as a web community, we've screwed up one of these redirects, and we'll talk a little bit about that. And then of course, there's the you screwed up versus we screwed up. And again, most people that have come at it from building just a pure front-end web app, most of the time when there's an error, they just throw an exception and it returns an HTTP 500. But as a developer consuming your API, I want to know if I screwed up or you screwed up. And so the choice between a 400 series message and a 500 series message actually matters. In fact, 500s, I'm not going to act on. I'm just going to assume your service is down. Versus 400, I'm going to go inspect my application to make sure it's using your API correctly. And of course, there's always my favorite, I'm a teapot, which really screws them up. Speaking about redirection for a quick second, this is just a side note just to mention that as a web community, we've screwed up how we use redirects. There's really kind of a couple of things that redirects are trying to tell you. If you send back a 301, we're saying, hey, you got the wrong resource. Don't call this ever again. Call this new URL. And actually, when you're doing this on the web with web browsers, with bookmarks, there's an interesting, I don't know if you've ever noticed this with your bookmarks in whatever browser. If I were to return you a 301 with a new URL, it'll actually update the bookmark in your web browser and say, here's the new page, so it never goes back to that old link. So permanent means it's actually completely moved, never come here again. Versus, temporary means you can keep coming here, but for now, just go over here. Now, we've actually screwed up, unfortunately, the use of 302 and the meaning of that to the point where the web community as a whole has basically scrapped the use of 302 in favor of 307 for doing temporary redirects. So just something to be aware of. Again, if you're picking HTTP as your protocol, if you're doing a temporary redirect, you should be using 307 instead of 302. And the reason is because most people, when they're trying to tell the browser that the next step in the process is over at this URL, actually ended up using 302s, and that's not really the right semantics. And so where this is important today, for example, I'm assuming everybody's logged into some service using their Twitter account or Facebook account or Microsoft account. That's actually a step in the process where you're telling the browser, go here, enter in your credentials, and then the service is saying, okay, you've entered in your credentials, they're valid, now go back to the application and provide this token. And what it's actually doing under the covers is sending an HTTP 303 saying the next step in the process is here. It's not a redirect, we're just kind of moving you along the workflow. And unfortunately, a lot of browsers don't actually treat that correctly, and they've because we've used a lot of 302s in the incorrect way. So just kind of keep that in the back of your mind if you're picking HTTP as your protocol. So getting back to the code, let's talk a little bit about how you would handle documentation and versioning and a few other pieces. So let's go ahead and take a look at our API now. So I'm just going to go ahead and build this up. So I can go to API tasks. And so this is going to do an HTTP GET. It's going to call my tasks without an ID. And as soon as the browser and everything churns away here, I should get back essentially my list of tasks associated with my user. There we go. Sorry? OK. So in this case, because I didn't specify a response format, Web API's behavior here is to return XML. In fact, actually, if we look under the covers, let's pull up the Browser Explorer. We can go take a look at our API here, and we can see, I don't have Zoom it running. So we can see here, oops, oh, lovely. OK, yep, so accept here, so I can say, hey, here's my request, get me the list of tasks. I'll take back HTML, I'll take back XML, and I'll take back XHTML, and I'll also take back WebP formats, and then anything else, worst case scenario if you don't have that, but I really prefer these sorts of formats. And so that's exactly what Web API has done, is it's returned back an XML set of data. And this thing actually works so well in terms of how you design it, you can kind of get the exact same fidelity that I can just go in and swap out my implementation in my web app. So in this case, just to prove to you this code works exactly the same, let's go swap out the implementation. So I'll go down to my view. And here I'm just using Telerik's Kendo UI, great web API framework, plug. So let's go ahead and swap in the URLs. So in this case, I'm going to say, go get me the URL for the route, and I want to use the default routing rules. I don't need to create a special rule. And we will go and say, default HTTP route. I want you to go to the controller and pull up the default route for getting from the tasks. So that's going to generate basically this URL API tasks. But just to show you that in action here, so I'll just make sure I've saved it. Let's go ahead and do the refresh. And this time it broke because I stopped the process. So we'll let this guy load up here in just a second, and we will get our list of tasks here. So while that's loading up, what's nice about this here, so yeah, here I'm calling /API/tasks, And unfortunately, I restarted the process, so oh, there it goes. There's all my data. And voila, I've got access to my data. I can see here it's coming back in JSON. So I've done no changes on my client side, but I can make the behavior of Web API work really kind of just in the same way that I would have back in my MVC days. Now, of course, this is a great little demo trick, and it assumes that when you designed your API in the MVC days that you still tried to follow things like get, post, put, delete, and so on to make it work. Again, most people and most APIs that I've seen when they've done AJAX stuff have really just done get and post and then abused the heck out of post in terms of what it can do. All right, so this is great. We've got an API now, and we can see here that it works. But how do we start providing some friendly documentation around that API? And the good news is that Microsoft's actually shipped a package through NuGet to help you provide documentation, because what's an API if you can't actually learn about it? And this one's the help page package for Web API, and it's only one of a couple of options out there. In addition, you can obviously create your own, but the advantage of doing the API package here is that it will actually automatically consume the documentation out of your application. So for example here, if I just say tasks controller, and if I go here and try and generate documentation, I'm just going to use GhostDoc just to spit out something here. Obviously, it'd spend some time, write it properly. We'll go ahead and get some documentation. So let's go ahead and rebuild that. So when you add this package, it's going to add an area to your application. And again, much in the same way, because Web API is built on the same foundation as MVC. In this case, it's just the /help page, and it's going to add a route into your route collection called /help. And of course, you can configure that if you already have a /help. So have no fear. But if I go to /help now that I've got documentation on there, and of course I've got to remember to hit run on the app, it will go ahead and give me a list of documentation. Now, while that's actually loading up, I'll show you an alternative to that documentation called Swagger. And so there's a kind of an emphasis on how do I do automatic documentation for this stuff, because nobody wants to write this stuff by hand. What's neat about it here is it says, hey, here's how to get it. Here's a sample of the return. So this is actually reading the object and generating out a sample of the object for you. I've written none of this by hand. And here's the version in XML. Here's how you call it. Here's some documentation, completely grokking it right off the documentation I define in the code. I get full developer level documentation. And this is great. It's a great starting point. You can build upon it because it's included in your project, and it's just really just a bunch of reflection and some MVC pieces. You can build on it. And then as well, you can get, some people have taken things like Swagger, which was originally developed, I think, for the Rails audience, and ported it as well to MVC. And what I like about this one here is not as, the style, first off, is a lot more compact, but I'm going to get similar sorts of information, but I'm also going to actually go poke at the API right from here and I can try it out. And I think that's really kind of cool for providing documentation. This is one of the advantages of picking HTTP as your protocol. If you try to do this with WCF and the HTTP protocol on WCF, at best you get a help page that will allow you to execute operations, but they will stop you if you use anything other than a primitive type for your input. It kind of says, I don't know how to generate that, and kind of gives up. In the Web API world, they've kind of solved a lot of that problem. So Swagger is another alternative to the documentation. There's a port in NuGet that actually applies this to Web API. So you kind of got the out-of-the-box stuff, which is great, very basic, absolutely essential that you should do something. This is a great place to start, or you can kind of go to a much richer option through Swagger. And again, you can customize the skins and make it look like your app and so on, which is pretty much what I did here, is to make it look like it's not a completely separate experience from my core application. So that's documentation. So let's talk a little bit now about versioning, because obviously over time you're going to change your API. You're going to either add functionality or you'll make breaking changes. And how do I deal with that? Well, in the old MVC world, there really wasn't a prescribed way of doing versioning. In fact, versioning as a whole is still a process that's being discussed as a development or as a web community. in terms of what's the best way to do it. And there's really three different mechanisms that are kind of most common out there. One is providing a header in your HTTP request saying, I'm explicitly expecting version 1 or version 2, or if I don't provide the header, just give me the, whatever the latest response is. The other one is through content negotiation. So, much like we saw that accept header that said application/HTML, well, you can define your own MIME types effectively and apply the version there. And then finally, URL versioning. And you've probably seen URL versioning, the /v1 in the URL. That really is great, but if you want to create like kind of permanent links to resources in a resource API, it kind of breaks the concept, because at some point I'm going to deprecate the v1 and remove the v1 of the API, especially when I'm on v8 or v9. I'm going to get rid of it. And so if I do URL versioning, effectively those links are going to die. And you can imagine some people have written apps against your API, and those apps are now 5 years old. They're still calling version 1 of the API, and you take away v1, and now all their links are broken. Versus if you used a version header, I could make decisions to redirect and not return a 404, but return something else that will either help them bridge that old structure or give them the new content in hopes that they'll still be able to process it. Now, again, three different mechanisms. There's no real strong consensus around which one of these mechanisms are kind of the preferred one. Personally, I like it simple and obvious right now, and a lot of the teams that I work with, we tend to do URL versioning, just because, again, it's just simple and explicit. I find having to explain to developers, especially, creating MIME types isn't something you do every day. Kind of content negotiation is just a lot harder to explain to people how to set up. Headers are probably your kind of second preferred method if you don't want to do URL versioning, because again, it's easy to explain to developers, oh, just put this header in, or if you don't, you'll always get the latest API response. So if I change the structure of the document and you didn't specify a header that said, give me version 1 or version 2, you're going to get the new version all the time. So they take on that risk. So let's take a look at how easy it is to add versioning into a web API application. And again, we look to NuGet. Somebody's already solved this problem for us through a package called web API versioning. Funny enough, these crazy names out there that are just so obvious. So let me just show you. I did include it. Yeah, there it is. ASP.NET Web API versioning support. Really easy. And what I like actually about this particular module is if you choose to pick the header version or the MIME type, this module actually supports all three different approaches. You don't need to kind of find a new module if you change approaches. But I'll just show you how easy it is to implement the URL versioning and why I think the URL versioning makes it really, really nice. So inside our API folder, we're going to create a version 1 and a version 2. Folder. And we'll go ahead and copy our controller in here and in here. And of course, we'll update our namespaces so that the compiler doesn't freak out. .version 2. So these effectively simulate two different versions of our API. In fact, we'll go back here and I'll just prove, just to prove to you this is a different API, we'll get rid of the post and the delete and the put. In fact, actually, we'll get rid of we'll just make it a get all, just so I can demo it on the command line here. So, or on the browser address bar. So version 1 just had a get and it just got all. Version 2, much more full, has a full set of functionality. So now you've got those two APIs. As a developer, from a developer experience perspective, really easy to see which code I'm working on. And it allows me to kind of be conscious of which version I'm responding to. So if I'm making breaking changes, I know that I've got to add a new version. And this version format, if you aren't already aware of semantic versioning, there's some rules around kind of what you should call the version. But if you change the major version, you usually do it when there's breaking changes. That'll certainly is a guide to kind of keep in the back of your mind. The next thing I need to do is actually wire up the module in my web API config just to tell it where to go, and that one's really easy. So in the global configuration, I'm going to go ahead and replace one of the controller selector, HTTP controller I can spell correctly here. And I'm going to go ahead and replace that. Oops, I got an extra set of brackets. And we'll go ahead and replace that with the routed version controller selector. That's a mouthful. Routed version controller selector. Configuration. All right, and we'll resolve types around that. Oops. And of course, you're not choosing to resolve types today. Versioning dot. Oh, route. There we go. There we go. Unfortunately, I got to talk to Mads about getting some sort of like mind reading piece on the API or on the editor, so I can when I typo, it will actually know what I meant. So we'll go ahead and add a version in here. And so by default, it's going to go ahead and force you to ask a version here. I could also provide a version in here if they don't provide a version. So I could say, by default, go to V2 and so on. But essentially what this has done here is this is really going to recognize that if I do V1 or V2, it's going to go find the version 1 and version 2 namespace and route appropriately to the controllers. And so this allows you to use a bit of the convention syntax and sugar. So let's go ahead and we got to actually update our API reference in our app. So let's go ahead and do that. So while that's loading up here. So the other thing we need to do is when you're going to say, going to generate it, I want you to actually use the version 2 API. And, not remove, replace. It's getting close to a time to reinstall. Luckily, I hear there's an RTM coming around the corner. So this is going to load up my app, and it'll go ahead and hit the V2 API because I've changed the update, and then I'll show you that underneath the covers that I can also hit the V1 API and show you that there's my call, it's pending, it's going out to my database and grabbing lots of stuff and returned it, and voila. But now if I go ahead and access the app, localhost /v1/tasks, I'll still get my V1, but just to show you that other piece isn't there, I'll go to /2, and it's just going to ignore this because it's going to assume the default route. So I can't actually get a specific task from it because it's going through the V1 API versus if I did this to the V2 API, it would give me the exact result. So that's just kind of a quick show as to how you can do versioning inside your API. Really easy with Web API and the ASP.NET versioning task. And again, I think it's really slick in how they've done this using convention because it makes it really easy from a dev experience perspective to know which version of the API I'm working on. And of course, you could under the covers share some of that code and do all the usual maintainability stuff that you may want to do inside your app. But I certainly would keep my V1, V2 APIs because behaviors I would expect are different between the two. So as you've gone through and built your API, you got to ask yourself, from a design perspective, are we RESTful yet? And some people, like anything in architecture, get really, kind of dogmatic about, the approach. So, we got to be completely RESTful compliant. So it means we have to have hyperlinks everywhere, and it's got to be fully self-discoverable and all that stuff. My argument is really, start with the minimum. Decide that, come up with great URIs that are explanatory, that make sense for your application. Make sure you use HTTP properly. If you do those two things, you're going to make it really easy for me as a developer to consume your API and really going to be able to do it across platforms, because those things are universal. They're not .NET specific. They're not Java specific. They're really universal if you implement HTTP correctly. Whether you go as far as doing full hypermedia where everything links and is self-discoverable, that really depends. Honestly, I haven't written an app that can auto-discover your API based on a RESTful endpoint. So I question the value proposition of going for full hypermedia if I'm thinking from just a pure dollars and cents investment perspective. It's nice, but I don't know how necessary it is in a lot of the scenarios. One of the other things you need to think a little bit about is access. And how you manage access to your API, because obviously, it's great to provide an API that's public, but even if you provide a public API, occasionally you have to shut down people that are bad users of your API. And so even if you're going to offer your API for free, you should think about something like an API token or a key that allows you to block requests if somebody goes and does something weird like fire 5 million requests per second at your endpoint, and you need a way to be able to block that at the load balancer or at the some sort of layer 7 router ahead of your actual servers. So access is kind of important. One of the things you should be thinking about, though, of course, because you're going to provide some sort of token over it, is wrapping your API in SSL. I don't think there's any question today, and if you talk to Troy Hunt, who's over actually in the next room right now talking a little bit about security, he'd tell you just wrap everything in SSL, period, just end of story. It's no longer the case that SSL requires so much more extra CPU to process than straight up HTTP. We've solved a lot of those problems through SSL offloading in the kernel. We've solved it through some of the hardware constraints. So just wrap everything in SSL. Certificates are dirt cheap. You don't need to buy the $5,000 green bar certificate for your API. The $20 one will work just as well. So just go out and just wrap your API in SSL. Just don't even make that an option. But what you do want to think a little bit about is how you're going to authorize users against your service. And it really depends on the usage scenarios you see for your service. For example, if you're just going to do this for 5 or 6 partners or customers out there and they just need something simple, you could do something like basic authentication. Really, really easy. Every HTTP client out there understands basic authentication. You don't really need to do a lot of explaining for that. But just keep in mind that when you're passing things across the wire, it's always effectively sending the password in clear text. It looks like it's encrypted, but it's really just a base 64 encoded string. That's not encryption. So just kind of keep that in mind, that it's always coming across in clear text. The other thing as well to think about is an API key, and this is kind of my preferred starting point for a lot of kind of basic APIs. And really, this is just a shared secret between you and the API, or you and the person on the other end. It's not unlike basic authentication, but it kind of by essence allows you to put some nuance around the key. For example, if you're using Azure Mobile Services, you basically go ahead and generate this key, but then you've got the ability to regenerate the key if something happens, like it gets disclosed. API keys, unlike passwords, gives you that nuance that allows you to say when you're designing it, hey, here's a key, and when you want to, you go ahead and regenerate the key. The biggest thing is to make sure that you understand where you're storing it and where you're sending it along. So typically you can send it across in the header, the query string, or the body of the message. Again, this is something that feels more appropriate for the header, although I've seen people pass along in the query string as well as the body. The header, kind of honestly, from a real life kind of doing this thing seems to work the best. And one thing you should be also thinking about is how those keys are generated as well, because you're sending a pre-shared secret. And there's a good discussion on Stack Overflow around HMAC-based keys that if you're going down this route, I would really encourage you to go ahead and read. The final thing to think about is OAuth. And OAuth is really, really interesting if you want to build services that other people build applications on top of and expose that to the user. So you've probably used OAuth if you've used something, like I said, to log in with your Twitter or Facebook account. It redirects you to the service that you're consuming from the application, says, please log in, and then it tells you this application is requesting X, Y, and Z. Are you sure you want to do that? And then it redirects back. OAuth has got a number of different scenarios it tries to solve, and there's a lot of investment in this around, in particular, the next generation called OpenID Connect. So I definitely encourage you to think about that. But again, most scenarios, if you're building a small API for use by a handful of customers, OAuth may be a little too heavy. There's a lot of concepts to grok. The advantage, like I say, of OAuth are things like, for example, the two-legged auth or the three-legged auth scenario. So the application, the way this works with OAuth is the application requests an authorization code from the service. Then it's going to go hand that authorization code to the user. The user is going to go ahead and access the service with that authorization code, and the service is going to say, hey, application's trying to access this, are you sure? And then the service is going to redirect the user back to the application once the user authenticates with basically a token in hand. And then the application is going to use that token to get a real live access token from the service. So there's a couple of tokens at play, but it's a neat way for applications to get delegated access to services out there. The downside is you require that step where the user actually acknowledges access to that service, and that may not be something you want to do. And OAuth also solves that through things like the two-legged auth scenario, where the application's basically confirming on behalf of the user access. This is a whole different area, and this is where you get into the stickiness of OAuth, and I'm not going to spend a lot of time on that. Instead, I want to kind of just focus on a basic implementation of security around it and show you, again, some of the easiness around Web API to do your own custom thing. So going back to our app here, Web API is just built on the ASP.NET stack, and we've got the concept of HTTP modules and the ASP.NET pipeline. So we can actually leverage that to our advantage and create our own authentication module that's basically sitting in the pipeline, making the requests and using things that are native to HTTP to be able to get that data. So in this case here, I've got a basic authorization module. It sits and looks for the authenticate request point in time, and is going to intercept that request, and it's going to go ahead and try and authenticate the user. And so what it's going to do is it's going to look for the authorization header. In this case, we're using basic auth. And if it is, I'm going to go ahead and parse that and try and authenticate the user. If not, I'll go ahead and request it from the user. So when I go ahead and authenticate the user, I'm just going through, just parsing out the credentials. Remember, I mentioned basic auth is base64 encoded, not encrypted. And then I'm going to go ahead and call my underlying API, whatever that is, to authenticate my user. So in this case, this is an example of using basic auth, the mechanism, to validate somebody's username and password against my own internal database. This doesn't have to be Active Directory that they tie against. So if you think about basic auth from an IIS perspective, often people think, well, I got to have my users now. Now I got to create all these Windows users for my API. Well, the nice thing about building on ASP.NET is you can completely override that behavior and have basic auth go ahead and attach to your own local database to be able to authenticate the user. And so we do that just by sniffing for the header, parsing out the header, and then authenticating the user. So using that module, super easy to do. You just simply go into your modules pipeline in IIS, add your module, and go ahead and off and start running the application. You'll be, we also have to specify authorize on our API here as well. On our API, because right now it's a public API, so let's go ahead and do that. And again, built on the MVC semantics, it's very easy to just kind of authorize that. And of course, you get all your usual kind of users, roles, and you can override this as much as you want. So I'll just prove to you that this is working off my local API. I don't have a Chuck Norris on my machine as a local user. It's just something that exists only in my database. Let's go ahead now and give that a run. And so I'll just do API v1 tasks. And geez, you'd think a solid state drive, this thing would run a little faster. So I'm already logged in, so it's already using my identity, but let's go ahead and do this from an incognito window. And so it's going to go ahead and prompt me. And you can see here I've already, I've injected myself into the stream here. So it knows it's not the local machine I'm authing against, but actually my app. Can I remember Chuck's password? I did. Good. And voila, I've got access to my data. So, there we go. So really easy to override the behavior. Again, here I'm just using basic auth against my application's database. Through this exact same pipeline, you could be sniffing for, instead of the authorization header, you can sniff for the any sort of API key header, and then validate that API key, and then push back as well. So there's all kinds of mechanisms you can do. And again, this is just standard ASP.NET stuff. Nothing here is Web API specific, but it's more about how you think about it and design your app to use that. And like I say, the three mechanisms that are most common out there that most developers will understand are username and password, API key, and OAuth. And so again, pick what's appropriate for your scenario, but also think simple. Think about, how do I get my developers to start using my API? So I mean, I know OAuth sounds sexy, but unless you got a real case for it, start simple. Get people using your API, because that's more important than getting everything just 100% perfect in the first version. The other nice thing you get with HTTP, when you pick that as a protocol, is you get a whole caching topology and framework and methodology, whatever word you want to use, built on the protocol. So if you run into, you're doing a lot of, kind of interesting data and it doesn't change very often, and you want to provide more performance around your app, most people will go down to their ORM and add a second level cache, or they'll implement ASP.NET caching to do that. But you're spending a lot of time building stuff in the back end of your app when you could actually have your clients do all the work for you on an existing caching mechanism. So HTTP already has this rich concept of caching, and it works through really two concepts, expiration and validation. So you can obviously do nothing, and HTTP will do its best to guess at what it can cache from a browser perspective, but it's better when you're explicit. So for example, with expiration, you can say content expires at midnight on December 23rd, or you can say it expires in 72 days or 12 hours or 2 minutes through an expiration header. The other thing as well you can do is provide validation as a different approach to that. And you can say this content was last modified on September 12th. And you can then, when I issue a request, I can say, give me access to order 1234 as long as it's been modified after September 12th. And we'll take a look at that in action just to see what that works. The other thing as well is you can provide e-tags as well to be able to say if something has changed. So an e-tag is basically just a hash of your content to say, this is the version I last have. Instead of me sending the entire object down, here's the hash of the object I have on hand. Only send me the new content if that content has changed. And you might ask yourself, I've got this small API, why does caching matter? More importantly, why does client-side caching matter? Well, if you're building mobile apps, you're going to quickly learn that network latency and network reliability is really a tough slog in the mobile network. And even back home in Canada, downtown Toronto, mobile connectivity isn't always great depending on what floor of what building or where the CN tower is relative to you. Latency can be a huge issue. And so when you're caching, when you implement this sort of client-side caching, you give your clients an opportunity to only use what sort of bandwidth and data they absolutely need to, and to leverage, again, some existing caching approaches that are already native to the stack. So you can also control cache behavior down the line. So kind of just jumping back here to this first picture, the cache doesn't just exist at the end client, the end application, or back at your server, but there's also caches in between along the internet. And some of this is internet providers caching at the edge to save their own bandwidth. Some of this is kind of security gateways, effectively trying to make sure that only the appropriate content goes across the wire. You can also put it in front of your own server. You can get things like HA proxy and all these other cache servers, and you can put it in front of your own server as part of a load balancing configuration, to be able to implement caching without your application even having to have been written for it. And so caching exists at multiple layers. And so you can control that cache as well and say when there's content that shouldn't be cached along the way. So a good example, for example, is if you get to a login page or some page with very sensitive information, you may want to tell all the people along the chain, don't cache this whatsoever. Just completely ignore that you've ever seen this before, pass the request, and always come back and get a fresh one. You can also tell hey, go ahead and cache the heck out of this thing. But when the freshness date, the expiry date passes, come back and check with me for an update. And there's proxies out there that will actually do intelligent pre-caching of content. And again, that's most popular inside corporate networks where everybody hits up the same news page every day. Well, instead of having 1,000 people go out to the internet and hit up the Google News page, I'm going to pre-cache that content. And so cache headers can play a role in how your application content is portrayed. Now, keep in mind, though, cache headers are really, most people, most devices along the way do try and obey the headers properly. Not every device gets it right. And so occasionally, even though you've set all the cache headers correctly, you may still get odd behavior out there. And it just could be something along the network chain. Again, that's kind of one of those edge case scenarios that you'll run into. But just kind of keep that in mind, is that it's a standard, but if it's fully respected, that's a different question. And certainly ISPs do a lot more aggressive caching than we think that they do. So let's talk about how do we implement caching inside, or kind of see some caching in action. So again, kind of going back to NuGet, this is a solved problem. So there's a series of packages called Cache Cow, and they've implemented a couple of different mechanisms for doing caching. One that's actually has as much knowledge to go back to your server and do the querying on your objects to make sure nothing has changed, through to just straight E-tag generation on the fly. I'll just show you the basic implementation just to give you a sense here. So I've done nothing to my code and my web API code, and we'll enable caching here in one line of code. And suddenly I'll have caching enabled on my app that will reduce the load here. So let's go back to my web API config here. And what I'll do here, and again, this is just a simple example just to give you a sense of how easy it can be to get on board with this stuff. Of course, you've got lots more control over it, and we'll talk a little bit about that when you see the example in 1 second here. So I'm just going to add the default caching handler to the API code. And if I don't think I still have do I still have a network window up? So I can go back here, and I can see here on the response, I've got no real caching mechanisms here. Zoom it here is having a problem getting below for some reason. Oops. Let's do this since. There we go. So there's not a lot of caching kind of going on in my response headers. It's just basically saying don't cache this response. It's expired the minute you got it. And there's really kind of no real info. So now that I've implemented just some basic caching, what will happen here is if I go ahead and rebuild this and reissue the same request, I'm going to get a very different response out of this here. So we'll go ahead and start back up. That guy's loading here. We'll just clean it up to the side. So what we're going to get generating out of this effectively is an E-tag. And, oops, why did I? There we go. So actually, we just saw it in action here. But so adding this particular package here starts to change some of the instructions. It gives us an E-tag to start working with. And an E-tag, like I said, is just a hash of the response content. So in this particular case, it inserted an HTTP module that sits just before you output the response and calculates a hash on it and then sends that along. And now what I can do essentially is take that response and pass that E-tag back and say, go give me this content if it's changed in terms of this hash value. And so let's go do that. We'll do that with Fiddler because it's a little easier to actually do in Fiddler. So let's go ahead and just refresh the page. There's my V1 task here. So let's go ahead and move this into our composer. So what we can actually see here is, because since the browser's already done it, it's already passed in here. I was just going to actually manually type this in from the last request here. So it's already passed in. The browser's already intelligent enough to kind of add. It says, hey, you had an E-tag the last time I asked for it. Let me go ahead and pass that along the next time. So you can see here, if it only give me the response if it doesn't match this hash value or if it's been modified since this date. And so if I go ahead and execute that, what's going to happen here is I'm going to get back an HTTP 304. And a 304, again, this is where we get into response codes and why they matter, says not modified, and it's got an empty body. Now, you might have asked yourself, okay, this is great. I got free caching by adding a module and all that sort of stuff, but my server still had to do the work to generate the content. This kind of module out of the box will simply just take the end result at the end of the ASP.NET pipeline, calculate the hash, and pass it along. Did I really save anything? And the answer is yes, absolutely. Sometimes it's not the server overhead that matters, it's the actual transferring it across the wire, especially when you're building mobile apps. What's most important actually is the bandwidth between me and the server, not the server overload or the server overhead, because I got cores and cores upon cores that can process stuff really quickly, but I got a really slow network. And so by just implementing this module, I've already got some benefit for my clients that are developing my mobile APIs. Now, of course, this framework is completely extensible, and you can choose to generate that tag yourself. And so if you want to take this to the next level, you're going to generate what's known as a strong E tag. So you see the w/ in front of this? This acknowledges that this is what's called a weak E tag. I generated it through some automatic algorithm, and it's going to be reliable most of the time, but it's not 100% reliable. And so you can generate what's known as a strong E tag by putting your own code in the pipeline that could do something like, I'm going to check the last modified tag on the in the database before I return the object, or I'm going to calculate my own hash based on 3 of the 5 properties. Whatever the logic you want to do to kind of say, no, this is actually a reliable hash representation of the object or the resource, and then in which case you can send back the E tag without the w/ to go along with it. So caching, really easy to add in. And again, most important, honestly, on the client side when you're building APIs. Don't jump right back to the server and start adding caching to your entity framework and Hibernate or your ASP.NET caching. That's honestly, with the amount of processing power we have out there today, that's not the thing that's the most important. The other great thing about the API world, and because it's become so hot, is we're starting to see vendors pop up that provide specific tooling around APIs. RunScope was kind of one of the latest guys on the scene that essentially implements a proxy that you can use in between your app and the API if you want to debug and see what's actually going on. There's all kinds of services, though, that are popping up around the API world in particular. For example, if you have an existing API and you want to actually add an API key and do some measurements against it, there's services that will effectively proxy your API and provide you a security layer without you having to write one. So if you've got one today and you want to simply just kind of make it right for the public and add some of those pieces, you can go basically buy that capability. Likewise, if you're an internal corporate person consuming APIs from the external world, and I don't want my Google Maps API key to be shared amongst every single developer in the organization, you can get internal API proxies that will call out on behalf of your application out to these services out there. And so that's really useful when you want to provide governance around external API usage from inside the firewall as well. So there's lots of stuff coming up around APIs. I'd really encourage you to, if you're here because you're interested in APIs, to keep your eyes open and don't think you have to build everything yourself. There's some great plumbing out there, not just NuGet packages for web API, but services that you can use that to help you write some specific things. Most importantly, pick a design pattern, though. Determine whether or not you're going to be RPC, message-based, or REST or resource-oriented, because you're just going to help me as a consumer of your API understand how to use your app. And the book Service Design Patterns is a great place to kind of reflect on that. And then there's always, of course, some great guidance out there in terms of things to make sure that you consider as you're designing your APIs. Did we implement security? Did I document it? Did I deal with error handling appropriately? Some great checklists and some guidance out there around designing usable APIs. And again, I'd encourage you, much like what we did when we were building official community and trying to build things like a commerce experience for people that were using online commerce for the first time, we grokked off what the big guys were doing. We said, how can we build a great shopping cart experience? Well, let's look at what Amazon and eBay and all these other guys are doing, because they've got boatloads of money invested in things like usability. On the API side, I'd be looking at what's Twitter doing, what's Facebook's doing. Although Facebook's probably not a great example. Their API isn't very pretty. But what are some of the big services doing out there around API design? And what are some of the trends that we can follow and some of the conventions that we can connect with to make it easier for people to consume my API? Because a successful API is one that's actually being used by people. So there's some related content out there, other sessions that you may want to think about if you're interested in this. Azure Mobile Services is a great way to build a set of APIs if you want, not just for mobile phones, but we'll actually be talking about a little later in this room about how I used Azure Mobile Services to connect to a Tesla Model S and provide a couple of services and an API around that. Please fill out your evaluations. There's a Sculpt mouse to be won, and of course, there's all kinds of other fun resources out there. Thank you very much, and hope you enjoyed the session.